In the vastness of space, everything we know, everything we are, is smaller than a grain of cosmic sand. Welcome back, curious minds. Your comments on our last video were, let's say, interestingly profound. You asked for more mind-bending content, and we heard you. Whether you're watching this at 3 a.m., trying to fall asleep, or just seeking to expand your consciousness, we've got something special for you today. Imagine for a moment that you're floating in the endless ocean of space. Every direction you look, there are mysteries so vast, so incomprehensible, that they challenge our very understanding of reality. From clouds of cosmic alcohol that taste like raspberries, to planets made entirely of diamonds, to stars that devour their own solar systems, the universe is stranger than anything we could have imagined. In the next 2 hours, we're going to take you on a journey through some of the most mind-melting facts about our universe. Facts that will make you question everything you thought you knew about reality. And trust us, we've seen your late-night comments. We know exactly how these revelations hit different when you're in that special state of mind. So, get comfortable, maybe grab some snacks, turn down the lights, and prepare your mind for expansion, because we're about to begin with something that will completely reshape your perspective of our place in the cosmos. Imagine holding a single grain of sand between your fingers. Such a tiny speck, barely visible to the naked eye. Now picture this. If that grain of sand was Earth, our entire Milky Way galaxy would stretch across the United States. Pretty incredible, right? But even that comparison barely scratches the surface of the true scale we're dealing with. Because out there in the vast cosmic ocean we call the observable universe, there are over 2 trillion galaxies, each one a collection of hundreds of billions of stars. Let that sink in for a moment. 2 trillion galaxies. If you spent just 1 second counting each galaxy, it would take you over 63,000 years to count them all. And remember, each one of those galaxies contains hundreds of billions of stars. The mathematics of it all becomes so vast that our human brains simply aren't equipped to truly comprehend these numbers. Here's where it gets even more mind-bending. If you were to take just one single star from each of these 2 trillion galaxies, just one, you'd already have more stars than there are grains of sand on every beach on Earth, every shoreline, every desert, every sandbox combined. And that's just taking one star from each galaxy. The actual number of stars out there? It's so incomprehensibly large that mathematicians had to invent new numerical terms just to express these quantities. But numbers alone don't tell the whole story. Each of these galaxies is a city of stars spread out across distances that make light itself take thousands or even millions of years to cross. When we look up at the night sky, we're not just looking out into space, we're looking back in time. The light from even our closest galactic neighbor, Andromeda, takes 2.5 million years to reach us. What we're seeing is how that galaxy looked when our earliest human ancestors were just beginning to walk upright. And between these galaxies, vast stretches of near-empty space, dark voids punctuated by filaments of galaxies that form a cosmic web so large it defies comprehension. This web, when mapped by our most powerful telescopes, reveals a structure that looks remarkably similar to neural networks in the human brain, or the intricate pattern of the internet, as if the very large and the very small are reflecting each other in some cosmic dance. Think about this. Every time you look up at the night sky, you're not just seeing points of light. You're seeing billions of years of cosmic history, trillions of nuclear furnaces burning across the void, each one potentially harboring its own solar system, its own planets, its own possibility for life. The light from these distant suns has traveled across unimaginable distances through cosmic dust and gas, bending around gravitational wells just to reach your eyes in this precise moment. And we're still discovering more. Every time we build a more powerful telescope, every time we look deeper into the cosmos, we find more galaxies, more stars, more possibilities. The James Webb Space Telescope, humanity's most powerful eye on the cosmos, is revealing galaxies so distant that their light has been traveling toward us since nearly the beginning of time itself. The scale of it all raises profound questions about our place in this cosmic ocean. In a universe so vast, with numbers so large they exceed our ability to comprehend them, what does it mean to exist on our tiny grain of sand? Are we, as Carl Sagan once said, a way for the cosmos to know itself? Or are we just one of countless experiments in consciousness, playing out across an infinite cosmic laboratory? These aren't just abstract questions. They're fundamental to understanding our place in the universe. Because in a cosmos this vast, with possibilities this endless, one thing becomes clear. We are simultaneously infinitesimally small and incredibly rare. The atoms in our bodies were forged in the hearts of dying stars, making us, quite literally, children of the cosmos. We are the universe experiencing itself, contemplating its own existence from our tiny vantage point on this cosmic grain of sand. But this is just the beginning of our journey through the cosmos. Because when we start to look closer at what's out there in those trillion galaxies, when we begin to understand the bizarre and beautiful phenomena that exist in the space between spaces, well, that's when things get really interesting. In the vast cosmic ocean we've been exploring, there's a question that has haunted humanity since we first looked up at the stars. Are we alone? The answer, as we're beginning to discover, is becoming clearer with each passing year. And it's not just speculation anymore, it's mathematics. Let's start with what we know for certain. In just the past few decades, we've confirmed the existence of over 5,000 planets orbiting distant stars. These aren't just any planets. These are worlds we've actually detected, measured, and studied, each one a potential story, a potential cradle of life waiting to be discovered. But here's the truly mind-bending part. These 5,000 planets are just the ones we can see with our current technology in the tiny fraction of space we've been able to study. NASA's estimates paint a picture that's almost impossible to comprehend. In our Milky Way galaxy alone, just one galaxy out of those 2 trillion we talked about, there are at least 100 billion planets. That's not a typo. 100 billion worlds, each with its own story, its own composition, its own potential for harboring life. Think about that number for a moment. If you were to visit one planet every second, it would take you over 3,000 years just to visit the ones we've already discovered. But to visit all 100 billion in our galaxy, it would take longer than the current age of the universe. And remember, that's just in our galaxy. But it gets even more interesting when we look at what we're finding. These aren't just barren rocks floating in space. Many of these worlds exist in what scientists call the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist on their surface. Water, the key ingredient for life as we know it. And we're not just finding a few of these worlds, we're finding them everywhere we look. The diversity of these planets is staggering. Some are rocky worlds like Earth, others are ocean planets covered entirely in deep seas. We've found planets orbiting two suns, like something out of Star Wars. Planets with years that last only a few Earth days. Worlds where it rains molten glass or iron. Each discovery reveals just how creative the universe can be in crafting potential homes for life. And here's where the mathematics comes in. When we look at the building blocks of life, like organic compounds, amino acids, the basic chemicals needed for biology, we find them everywhere. They're in meteorites that fall to Earth. They're in the dust between stars. They're in the atmospheres of distant planets. The universe, it seems, is practically cooking with the ingredients for life. Consider this. On Earth, we find life in almost every environment we look. From the deepest ocean trenches to volcanic hot springs, from the driest deserts to the frozen Antarctic, life finds a way. It adapts, it evolves, it persists. If life is this tenacious on our single planet, what are the odds that in 100 billion other worlds, not a single one has managed to spark that same cosmic experiment? The famous Drake equation, which attempts to calculate the probability of intelligent life in our galaxy, has been refined over the years as we've gathered more data. And with each refinement, with each new discovery of potentially habitable worlds, the mathematics points more and more clearly to one conclusion. We cannot be alone. Even if we take the most conservative estimates, even if we assume that only a tiny fraction of potentially habitable planets actually develop life, and only a tiny fraction of those develop intelligent life, the sheer numbers involved make it virtually impossible that we're the only ones out here. It would be like saying in all the grains of sand on all the beaches on Earth, only one contains a specific mineral. The odds are astronomically against it. This realization doesn't diminish our significance. If anything, it enhances it. We are part of something larger, a cosmic community we haven't yet met, but that mathematics tells us must exist. Every new planet we discover, every new solar system we map, brings us closer to answering that ancient question that has echoed through human consciousness since we first looked up at the stars. We might be alone in our corner of the galaxy for now, but out there, in the cosmic dance of 100 billion worlds, life is almost certainly taking its own unique steps, writing its own story in the great cosmic narrative. In the depths of space, roughly 150 light-years from Earth, there's a cosmic cloud that contains one of the most unexpected discoveries astronomers have ever made. Meet Sagittarius B2, a massive cloud of gas and dust that holds an intriguing secret. It's essentially a floating cosmic brewery containing enough ethyl alcohol to make 400 trillion pints of beer. But this isn't just any ordinary space cloud. It has another surprising characteristic. It tastes like raspberries and smells like rum. Let's take a moment to understand just how extraordinary this discovery really is. Sagittarius B2 isn't just a small pocket of space. It's a vast molecular cloud spanning approximately 150 light-years across. To put that in perspective, if you could drive your car through space at highway speeds, it would take you over 880 billion years to cross it. This celestial giant sits near the center of our Milky Way galaxy, in a region that astronomers call the Central Molecular Zone. But what makes this cloud truly remarkable is its chemical composition. Using radio telescopes, scientists have detected over 50 different chemical compounds within Sagittarius B2, including something that came as a complete surprise: ethyl alcohol, the same type of alcohol found in your favorite beverages. And not just a little bit, we're talking about an amount so vast that it defies comprehension. The 400 trillion pints of potential beer floating in this cosmic cloud is a number so large that it makes our Earth's oceans look like a drop in the bucket. If you tried to count each potential pint at a rate of 1 per second, it would take you longer than the current age of the universe, multiple times over. This is the scale we're dealing with in space, where even something as familiar as alcohol exists in quantities that stretch our imagination to its limits. But the story gets even more fascinating. Within this same cloud, scientists have discovered ethyl formate, the chemical compound responsible for the flavor of raspberries and the smell of rum. This means that if you could somehow fly through this cloud, which you couldn't, because space is a vacuum and you'd need a spacecraft, you'd encounter molecules that would taste like raspberries and smell like rum. Though we don't recommend trying this, as the cloud also contains numerous other less pleasant compounds. The presence of these complex organic molecules tells us something profound about the chemistry of space. We often think of space as empty and lifeless, but these discoveries reveal that it's actually a vast chemical laboratory where complex organic compounds form naturally. The same processes that created these alcohols and flavor compounds in space might also have played a role in creating the building blocks of life on Earth. How does this cosmic brewery work? It all comes down to the interactions between dust and radiation in space. When stars form within these molecular clouds, they emit radiation that interacts with the surrounding dust and gas. This energy drives chemical reactions that wouldn't be possible under normal conditions on Earth. The result is a complex soup of organic molecules, including our friends ethanol and ethyl formate. These space clouds also serve as nurseries for new stars and planetary systems. The same cloud that contains all this alcohol is also birthing new suns, which will eventually have their own solar systems, complete with planets that might one day harbor life. It's a reminder that the universe is constantly creating, mixing and transforming matter in ways that continue to surprise us. The discovery of Sagittarius B2's chemical composition has implications beyond just being an interesting cosmic curiosity. It helps us understand how complex organic molecules can form in space, which in turn helps us understand how life might have originated on Earth and where else it might exist in the universe. If complex organic molecules can form naturally in space, then the ingredients for life might be more common throughout the cosmos than we once thought. This cosmic cocktail cloud also reminds us of something important. The universe is not just vast and mysterious, it's also surprisingly familiar. The same molecules that give raspberries their taste and rum its smell exist out there in the depths of space, floating between the stars. It's as if the universe has a sense of humor, creating a giant cosmic bar that we can observe but never visit. Sagittarius B2 stands as a testament to the incredible diversity and complexity of our cosmos. In a universe that seems to stretch endlessly into the darkness, we find pockets of space that contain familiar molecules arranged in extraordinary ways. It makes you wonder what other chemical wonders are floating out there, waiting to be discovered by our ever-improving telescopes and detection methods. And speaking of wonders in space, Wait until you hear about what's happening in another corner of our galaxy, where a star is doing something that would make even the Death Star jealous. In a corner of our galaxy, approximately 180,000 light-years away in the Small Magellanic Cloud, there's a cosmic phenomenon that makes science fiction look tame in comparison. Meet HV 2112, a star that astronomers have dubbed a Thorn-Zitku object, but you might know it better by its more dramatic nickname, the Death Star. Unlike its fictional namesake, this celestial body doesn't need a super laser to destroy planets. Instead, it's doing something far more dramatic. It's literally consuming entire planets, swallowing them whole and growing larger with each cosmic meal. What we're witnessing is one of the rarest and most bizarre objects ever discovered in astronomy. HV 2112 isn't just any star, it's what happens when a red supergiant star contains a neutron star at its core. Think about that for a moment. Inside this massive star is another star, an ultra-dense neutron star that acts like a cosmic garbage disposal, gradually consuming everything that gets too close. To understand just how extraordinary this is, we need to break down what we're looking at. A neutron star is already an extreme object. It's what's left after a massive star explodes in a supernova. These stellar remnants are so dense that a teaspoon of neutron star material would weigh about 1 billion tons. Now imagine this incredibly dense object inside another larger star. It's like a star within a star, a cosmic Matryoshka doll of stellar proportions. But how does such a bizarre object come to exist? The process is as violent as you might imagine. It starts when two stars in a binary system reach the end of their lives. One explodes as a supernova, leaving behind a neutron star. This neutron star then gets enveloped by its companion star as it expands into a red supergiant. What happens next is where things get really interesting. The neutron star, now inside its companion, begins to act like a cosmic vacuum cleaner. Its incredible gravitational pull starts to consume the inner layers of the surrounding star. But it doesn't stop there. Any planets or other objects that once orbited either star are gradually pulled in as well. These unfortunate worlds spiral inward, eventually meeting their doom in the gravitational maw of this stellar monster. Each time HV 2112 consumes a planet, the material doesn't just disappear. Instead, it becomes part of a complex series of nuclear reactions. The extreme conditions near the neutron star core create unique elements through a process called the S process, slow neutron capture. This makes Thorn-Zitku objects like HV 2112 some of the only places in the universe where certain heavy elements can be created naturally. The temperatures involved in this cosmic feast are almost incomprehensible. While the outer layers of HV 2112 are relatively cool for a star at around 4,500 Kelvin, the region near the neutron star core reaches temperatures of over 1 billion Kelvin. Any planets that fall into this stellar furnace don't just melt. They're completely broken down into their constituent elements, becoming fuel for the star's unique nuclear processes. What makes HV 2112 even more remarkable is how rare it is. Theoretical physicists Kip Thorne and Anna Zitkow first proposed the possibility of these objects in 1975, but it took nearly 40 years before we found a likely candidate. HV 2112 is possibly the first confirmed Thorn-Zitku object ever discovered, making it one of the rarest known objects in the universe. The discovery of this cosmic cannibal has profound implications for our understanding of stellar evolution and the life cycles of stars. It shows us that stars can die in ways we never imagined, creating conditions that forge new elements and reshape entire solar systems. Every planet consumed by HV2112 contributes to its unique chemical signature, leaving behind traces that astronomers can detect from Earth. But perhaps the most chilling aspect of HV2112 is what it tells us about the fate of planets. In our own solar system, we're safe from such a fate. Our sun will never become a Thorn-Zitku object. But somewhere out there, right now, entire worlds are being pulled into this stellar leviathan, their matter becoming one with the cosmic monster that consumed them. It's a reminder that the universe isn't just vast and beautiful, it can also be unutterably destructive. The study of objects like HV2112 continues to challenge our understanding of stellar physics. Each new observation brings fresh insights into these cosmic anomalies, helping us piece together the complex puzzle of stellar evolution and the fate of planetary systems. In the grand cosmic dance, even acts of destruction like this contribute to the ongoing cycle of stellar life and death that makes our universe such a dynamic and fascinating place. And speaking of fascinating cosmic processes, wait until you hear about what's happening every single second in our very own star. At this very moment, as you're listening to these words, an extraordinary process is taking place just 93 million miles away. Our sun, that seemingly constant ball of light in our sky, is performing a feat of nuclear engineering so massive it defies comprehension. Every single second, not every hour, not every minute, but every single second, it transforms 600 million tons of hydrogen into helium through nuclear fusion. That's equivalent to the mass of all the oceans on Earth being converted into energy roughly every 500,000 years. Let's break down what this actually means, because the numbers alone don't do justice to the sheer scale of what's happening. In the sun's core, where temperatures reach an astounding 27 million degrees Fahrenheit, 15 million degrees Celsius, hydrogen atoms are being smashed together with such incredible force that they fuse into helium. This process, nuclear fusion, is the same basic principle behind hydrogen bombs, but the sun is doing it on a scale that makes our most powerful weapons look like firecrackers. Think about this. A modern nuclear weapon releases energy equivalent to about 1 megaton of TNT. The sun? It produces the equivalent of 100 billion megatons of TNT every single second. That's like having thousands of nuclear weapons detonating simultaneously, continuously without pause for billions of years. Yet from our perspective on Earth, it's just another sunny day. The process powering this cosmic furnace is called the proton-proton chain reaction, and it's happening roughly 400,000 miles beneath the sun's surface, in its core. Here, the pressure is so intense, about 250 billion times Earth's atmospheric pressure at sea level, that hydrogen atoms have no choice but to fuse. Every second, the sun fuses about 620 million metric tons of hydrogen. But here's where it gets interesting. The helium produced only weighs about 616 million metric tons. What happens to the missing 4 million metric tons? That's where Einstein's famous equation E equals mc squared comes into play. That lost mass is converted directly into energy, following Einstein's principle that mass and energy are interchangeable. This energy, in the form of photons, begins a journey that can take up to 100,000 years to reach the sun's surface. Yes, the sunlight warming your skin right now actually began its journey when humans were still in the Stone Age. The amount of energy produced in this process is almost incomprehensible. Every second, the sun generates enough energy to power human civilization for about 500,000 years at our current rate of consumption. If we could harness just 1 second's worth of the sun's total energy output, we could power every city, every device, every vehicle on Earth for 500,000 years. It's producing so much energy that even at our distance of 93 million miles, enough solar energy hits Earth every hour to meet humanity's energy needs for an entire year. But here's what makes this even more remarkable. The sun has been doing this non-stop for about 4.6 billion years, and it has enough hydrogen fuel to continue for another 5 billion years. The consistency and longevity of this process is what makes life on Earth possible. The sun's energy output is so stable that it varies by less than 0.1% over thousands of years, providing the steady conditions necessary for life to evolve and thrive. What's happening in the sun's core also tells us something profound about our own existence. Every atom of carbon in our bodies, every atom of oxygen we breathe, every atom of nitrogen in our DNA, all of these elements were forged in stars through similar fusion processes. When we look up at the sun, we're not just seeing a distant ball of fire. We're watching the same process that created the building blocks of life itself. The sun's fusion reactor also represents something of a holy grail for human energy production. Scientists around the world are working to replicate this process through projects like ITER, International Thermonuclear Experimental Reactor, attempting to create sustainable fusion power here on Earth. If we could successfully harness fusion power, we would have access to virtually limitless clean energy. But despite our best efforts, we're still struggling to maintain fusion reactions for more than a few minutes, while the sun has been doing it effortlessly for billions of years. Perhaps most remarkable is how the sun contains this enormous power through the perfect balance of forces. The intense gravitational pressure trying to crush the sun inward is precisely balanced by the outward pressure of fusion energy trying to blow it apart. This cosmic ballet of forces creates the stable conditions that make life possible on Earth. It's as if the universe fine-tuned these parameters exactly right for stars like our sun to exist and sustain life. Every morning when we see the sun rise, we're witnessing the light and heat from countless nuclear fusion reactions that happened thousands of years ago, finally reaching us after their long journey from the sun's core. That warm sunlight on your face. It's the result of atomic nuclei fusing together in an eternal cosmic dance that began long before humans walked the Earth and will continue long after we're gone. But while our sun represents a perfect balance of cosmic forces, there are places in our universe where balance doesn't exist at all. Places so empty, so vast, that they challenge our understanding of the cosmos itself. In the northern constellation of Bootes lies one of the most enigmatic structures ever discovered in our cosmos, the Bootes Void, also known as the Great Nothing. Imagine a sphere in space so vast it stretches 330 million light-years across, and so empty that where we would expect to find thousands of galaxies, we find only a handful. To understand just how extraordinary this cosmic desert is, and why some scientists have proposed such radical theories about its origin, we first need to grasp the scale of this nothingness. To put 330 million light-years in perspective, our entire Milky Way galaxy is about 100,000 light-years across. This means you could fit over 3,000 Milky Way galaxies end-to-end across the Bootes void. In a typical region of space this size, we would expect to find roughly 10,000 galaxies. The Bootes void contains only about 60. It's as if something or someone cleaned house in this region of space, leaving behind an emptiness that defies our understanding of cosmic structure. The void's discovery in 1981 by Robert Kirshner and his team was so unexpected that it was initially met with skepticism. How could such a massive, empty region exist in a universe that's supposed to be more or less evenly distributed on large scales? The more astronomers studied it, the more perplexing it became. The few galaxies that do exist within the void aren't scattered randomly. They're arranged in a tube-like structure, almost as if they were deliberately placed there. This is where the conversation takes a fascinating turn toward the concept of advanced civilizations and their potential impact on cosmic scales. To understand why some scientists have proposed that the Bootes void might be evidence of an advanced civilization, we need to understand the Kardashev scale, which classifies civilizations based on their energy consumption and technological advancement. The Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev in 1964, defines three main types of civilizations. A Type 1 civilization can harness and store all the energy available on its home planet. This includes all solar, wind, geothermal, and other planetary energy sources. Humans aren't quite there yet. We're currently at about 0.73 on the Kardashev scale. We can harness significant energy, but haven't yet mastered our planet's full energy potential. A Type 2 civilization can harness the total energy of their star system. Think of massive structures like Dyson spheres, completely encompassing stars to capture all their energy output. This level of technology would allow for interplanetary colonization and energy usage equivalent to the entire output of their sun. A Type 3 civilization is where things get truly mind-bending. These hypothetical civilizations can harness the energy of their entire galaxy, roughly 100 billion stars worth of energy. They would have colonized most or all of their galaxy and would have technology that seems like magic to us, possibly including the ability to manipulate space, time, and even dimensions. This brings us back to the Bootes void and why some scientists have speculated about its unusual emptiness. The theory suggests that an incredibly advanced Type 3 civilization might have either consumed the matter in this region for energy, moved it elsewhere, or perhaps even found a way to leave our universe entirely, leaving behind this cosmic ghost town as evidence of their existence. The idea isn't as far-fetched as it might sound at first. Freeman Dyson, the renowned physicist who proposed the Dyson sphere, suggested that advanced civilizations would be characterized by their waste heat. The energy they couldn't use efficiently would be detectable as infrared radiation. The unusual emptiness of the Bootes void, combined with its peculiar structure of remaining galaxies, has led some scientists to wonder if we're looking at the aftermath of such a civilization's activities. However, it's crucial to note that this is still very much a fringe theory in the scientific community. More conventional explanations suggest that the void might be the result of smaller voids merging over billions of years through normal cosmic evolution. Another theory proposes that it could be the result of a cosmic supervoid, a natural phenomenon resulting from the way matter clumped together in the early universe. Yet the void continues to puzzle astronomers because of its extreme nature. The universe typically has a web-like structure, with galaxies arranged in filaments and clusters with smaller voids between them. But the Booty's void is different. It's too big, too empty, and too structured to easily fit into our current models of cosmic evolution. The existence of the Booty's void raises profound questions about our understanding of the universe. If it's natural, it challenges our models of how cosmic structures form and evolve. If it's artificial, a possibility that can't be completely ruled out, however unlikely it might seem, it suggests that the universe might harbor life and technology far beyond our comprehension. The few galaxies that do exist within the void are also unusual. They're active star-forming galaxies, which is unexpected in such an empty region. It's as if these galaxies are relatively young, having formed long after the void itself came into existence. This adds another layer of mystery to an already perplexing cosmic structure. Whether natural phenomenon or artificial construct, the Booty's void stands as a testament to how much we still have to learn about our universe. It reminds us that space isn't just a uniform scattering of galaxies. It's a landscape of extremes, where regions of incredible density exist alongside vast cosmic deserts. And perhaps most importantly, it reminds us that in science, we must always remain open to possibilities that seem impossible at first glance. Speaking of impossible-seeming things, let's talk about a place where the rules of time itself begin to break down. Picture yourself floating in space, watching something that defies everything we know about time and reality. You're observing a black hole, a cosmic object so dense and powerful that not even light can escape its gravitational pull. But what's about to unfold isn't just about gravity. It's about the very fabric of time itself, bending and warping in ways that seem impossible. Let's break down one of the most mind-bending phenomena in our universe: gravitational time dilation. Einstein's theory of relativity tells us something extraordinary. Time isn't fixed. It's flexible, like a rubber sheet that can be stretched and compressed. The stronger the gravitational field, the more time itself slows down. And nowhere is this effect more dramatic than near a black hole. Imagine you and a friend decide to conduct the most extreme scientific experiment possible. Your friend volunteers to approach the black hole while you observe from a safe distance. As they get closer, something extraordinary begins to happen. From your perspective, your friend appears to move slower and slower. Their movements become increasingly sluggish, as if they're swimming through invisible molasses. This isn't an illusion. It's actual time dilation in action. As your friend approaches the black hole's event horizon, the point of no return, their time literally slows down relative to yours. You would see their movements become increasingly delayed. Their radio signals to you would become more and more stretched out, their voice dropping to lower and lower pitches until it becomes too low to hear. But here's where it gets truly bizarre. From your friend's perspective, nothing unusual is happening to their own experience of time. To them, their watch is ticking normally, their movements feel natural, and their thoughts flow at their usual pace. Instead, they would look back at you and see something astonishing. You would appear to be moving faster and faster, as if someone had pressed the fast-forward button on the universe. As your friend gets even closer to the event horizon, the differences become more extreme. You would see them move so slowly that they appear to freeze in place. their final image would become stuck at the event horizon, like a photograph frozen in time. This is because at the event horizon, the gravitational pull becomes so strong that even light can't escape. The last photons reflecting off your friend would be stretched nearly infinitely, creating what physicists call the gravitational time dilation effect. But from your friend's perspective, they would cross the event horizon without noticing anything particularly special about that moment. The truly strange part is that as they cross this boundary, they would see the entire future of the universe play out in fast forward before their eyes. In the brief moments before the extreme gravitational forces would tear them apart, a process scientists call spaghettification, they would theoretically witness billions of years pass in the outside universe. This isn't science fiction. It's the actual mathematics of Einstein's relativity at work. We've even measured time dilation effects on a smaller scale right here on Earth. GPS satellites have to be programmed to account for time dilation because time moves slightly faster in orbit than it does on Earth's surface. Without these corrections, GPS would be off by about 11 kilometers per day. The mathematics behind this is both beautiful and terrifying. The closer you get to a massive object like a black hole, the more space-time curves. This curvature affects everything: light, matter, and time itself. The formula for time dilation tells us that at the event horizon, time as experienced by an outside observer would effectively stop. Think about what this means for our understanding of reality. Two people could experience the same moment in radically different ways, not because of psychology or perception, but because the fundamental nature of time itself has been warped by gravity. There's no correct time. Both perspectives are equally valid in their own reference frames. This has profound implications for our understanding of the universe. If time can bend and warp this dramatically, what does it mean for our concept of now? When we look at distant galaxies, we're seeing them as they were millions or billions of years ago. But if time itself is relative, then the very concept of simultaneous events throughout the universe becomes meaningless. Some physicists have suggested that this property of black holes might create serious problems for our understanding of physics. The fact that information seems to be lost forever in a black hole, since nothing can escape, appears to violate some fundamental principles of quantum mechanics. This is known as the black hole information paradox, and it continues to puzzle scientists today. The time dilation effects of black holes remind us that reality is far stranger than we could have imagined. Our common sense notions of time, that it flows steadily and equally for everyone, turn out to be an illusion born from living in the relatively weak gravitational field of Earth. Near a black hole, the true nature of time reveals itself, flexible, relative, and deeply connected to the fabric of space itself. And speaking of things that seem to defy our everyday understanding of reality, wait until you hear about this next fact, one that shows how the simple act of folding paper could theoretically bridge the gap between Earth and the Moon. At first glance, this might sound impossible, a simple piece of paper reaching the Moon. But this fact perfectly illustrates the mind-bending power of something we call exponential growth, where numbers don't just grow bigger, they explode in size beyond our ability to imagine. Let's start with a standard piece of paper. Your typical sheet of printer paper is about as thin as a human hair. Now let's follow what happens each time we fold it, keeping in mind that each fold doubles the thickness of our stack. After your first fold, your paper is now twice as thick. Fold it again, and it's 4 times as thick. A third fold makes it 8 times thicker than when you started. By your 5th fold, that single sheet is now thicker than a stack of credit cards. But we're just getting started. By your 10th fold, if you could manage it, your stack of folded paper would be about as tall as a coffee cup. Keep folding until you reach 20 folds, and theoretically, that stack would now be taller than most airplanes fly. But the real magic happens in those final folds. When you reach fold 42, your paper stack would theoretically be so tall it would stretch past satellites, past the International Space Station, beyond all our spacecraft, all the way to the moon, and even past it. The single sheet of paper folded just 42 times would make a stack tall enough to bridge the gap between Earth and its lunar companion. To put this in perspective, think about climbing a staircase where each step is twice as tall as the last one. Those first few steps are easy enough, ankle height, then knee height, then waist height. But by step 20, you'd be climbing past clouds. By step 30, you'd be higher than any plane has ever flown. Those final 12 steps would take you all the way to the moon. But here's where reality crashes into our mathematical daydream. No one has ever come close to folding a paper this many times, and it's physically impossible to do so. The current world record for paper folding stands at just 12 folds, set by Brittany Gallivan in 2002. She used an incredibly thin sheet of toilet paper that was nearly 3/4 of a mile long, and even then, she reached the absolute limit of what's possible. Why can't we actually fold a paper 42 times? The problem is simple. Each time you fold a piece of paper, you need enough paper on each side to make the fold. The paper also becomes exponentially more rigid and difficult to bend. By about the 7th fold, the paper becomes so thick and stiff that human hands simply can't fold it anymore. This fact teaches us something profound about how our minds work. We're naturally good at understanding simple addition, adding one number to another. But when things start doubling, our brains have trouble keeping up. It's the same principle behind how a single penny doubled every day for a month would make you a millionaire. Our minds just aren't wired to naturally grasp this kind of growth. The paper folding thought experiment also gives us a unique way to understand just how far away the moon really is. We often hear that it's about 240,000 miles away, but that number doesn't mean much to most of us. But thinking about a folded piece of paper somehow makes that vast distance feel more real, even if we can't actually create that stack. And speaking of astronomical distances, wait until you hear about what we're seeing when we look up at the night sky. Because some of those twinkling stars above us aren't what they appear to be at all. Picture yourself on a clear night, far from the city lights, gazing up at the vast tapestry of stars above. Each point of light seems to twinkle in real time, as if responding to your presence. But here's something remarkable. What you're actually seeing is an ancient message, a glimpse into the distant past. Those stars you're looking at? Many of them no longer exist as you see them. Some may have died millions of years ago, their final moments frozen in a journey across space and time. To understand this cosmic time capsule, we need to grasp an extraordinary fact about light. Light, though incredibly fast, isn't instantaneous. It travels at a speed of 186,282 miles per second, or about 671 million miles per hour. At this remarkable velocity, light from our sun takes roughly 8 minutes to reach Earth. This means when you feel the warmth of sunlight on your face, you're experiencing energy that left the sun 8 minutes ago. But our sun is practically our next-door neighbor compared to the other stars we see. Take Betelgeuse, for instance, one of the brightest stars in the constellation Orion. The light from Betelgeuse takes approximately 642 years to reach us. This means when you look at Betelgeuse tonight, you're seeing it as it appeared during the medieval period, around the time Geoffrey Chaucer was writing the Canterbury Tales. Even more mind-bending is the case of Eta Carinae, a massive stellar system about 7,500 light-years away. The light we see from it today began its journey when humans were just beginning to develop agriculture and settle into permanent communities. If Eta Carinae were to go supernova tomorrow, our descendants wouldn't know about it until the year 9524. This delay between an event occurring and our ability to observe it creates a fascinating paradox. We're essentially astronomical archaeologists studying the fossilized light of the cosmos. The further we look into space, the further we look back in time. When astronomers observe galaxies billions of light years away, they're seeing them as they existed billions of years ago, potentially before our solar system even formed. But this cosmic time delay isn't just a curiosity. It's also a crucial tool for understanding our universe. When astronomers detected the collision of two neutron stars in 2017, they were watching an event that occurred 130 million years ago, when dinosaurs still roamed the Earth. The light from this collision carried with it information about gravitational waves, the creation of heavy elements, and the nature of space-time itself. There's a profound poetry in this reality. Every clear night, we're surrounded by messages in bottles, cosmic postcards from different eras of the universe's history. Some stars we see might have already transformed into black holes. Others might have gone supernova, and still others might have given birth to new planetary systems. We're watching a movie of the universe where every star is on its own time delay, each telling its own story from a different moment in cosmic history. This celestial time lag also means that somewhere out there, 65 million light-years away, there's theoretically a planet where, if they had powerful enough telescopes, they would just now be witnessing the extinction event that wiped out the dinosaurs on Earth. Every moment of our planet's history is radiating outward at the speed of light, creating a spherical shell of information expanding through space. Perhaps most humbling is the realization that we ourselves are part of this cosmic light show. The light reflecting off Earth right now is beginning its own journey into space, carrying with it the story of our present moment to distant observers. In this way, every point of light in the night sky isn't just a star, it's a window into a different moment in time, a reminder that the universe we observe is not the universe as it exists now, but rather a beautiful compilation of moments from various chapters in the cosmic story. So the next time you look up at the night sky, remember, you're not just looking out into space, you're looking back in time. Those twinkling points of light are nature's time capsules, each one preserving a moment from the universe's past, waiting for your eyes to receive their ancient message. In this way, every stargazing session becomes a journey, not just through space, but through time itself, connecting us to the grand cosmic history that continues to unfold above our heads. In a universe that constantly challenges our understanding of what's possible, 55 Cancri E stands as a testament to the extraordinary. This isn't just another planet. It's a world that makes our most extravagant jewelry look modest by comparison. Located 41 light-years away in the constellation of Cancer, this super-Earth has a composition that would make any gemologist's head spin. It's largely made of diamond. Let's put this into perspective. Here on Earth, we consider diamonds precious because they're relatively rare, formed deep underground under extreme pressure and heat. But 55 Cancri E takes this to an entirely different level. This is a planet twice the size of Earth, with 8 times its mass, where the ground itself is composed of crystallized carbon stretching thousands of miles deep. Every mountain, every valley, every core layer transformed into diamond through astronomical forces we can barely comprehend. The numbers behind this cosmic jewel tell a story that sounds more like fantasy than science. The surface temperature reaches 4,400 degrees Fahrenheit, hot enough to melt titanium. A year on this planet lasts just 18 hours because it orbits so close to its star. To put that in perspective, while you're getting through a regular day at work, this planet has completed more than a full orbit around its sun. When scientists first spotted this world in 2004, they thought it was just another super-Earth, one of those planets bigger than our home but smaller than Neptune. But as our instruments grew more sophisticated, the data revealed something extraordinary. The mass and radius measurements pointed to a world unlike anything we'd seen before. A planet rich in carbon that, under immense pressure and heat, would crystallize into diamond. Here's a mind-bending fact. If we could somehow transport this planet's worth of diamond back to Earth, its value would exceed the entire world's GDP many times over. We're talking about a diamond roughly 3 times the size of Earth. Every single jewelry store on our planet combined wouldn't even begin to compare to a single mountain on 55 Cancri E. The existence of this diamond world completely reshapes our understanding of how planets form. Most rocky planets we know of, including Earth, came together in oxygen-rich environments, creating lots of silicates and minerals. But 55 Cancri E tells a different story. The planet formed in an environment so rich in carbon that it created something unprecedented in our experience. The numbers keep getting more fascinating. The host star, 55 Cancri A, contains more carbon than our Sun, suggesting this entire solar system formed under conditions dramatically different from our own. If you were to analyze just a cubic meter of this planet's surface, you'd find more diamond than has ever been mined in Earth's entire history. Recent observations have unveiled even more surprises. The planet shows significant temperature variations between its day and night sides, suggesting some form of atmospheric activity. Some researchers have detected evidence of superheated lava pools on its surface, existing alongside the diamond and graphite formations. Every new measurement adds another layer to this planet's remarkable story. Here's something to consider. While we've found over 5,000 exoplanets so far, 55 Cancri E stands out as one of the most exotic. Scientists estimate that as many as 1/3 of super-Earths could be carbon-rich, though not all would have the right conditions to form diamond. This means there could be dozens, hundreds, or even thousands of diamond worlds scattered throughout our galaxy, each waiting to be discovered. This discovery showcases just how far our technology has come. Just 30 years ago, we couldn't detect any planets around other stars. Now, we're not only finding them, but determining their composition from tens of light years away. We can analyze their atmospheres, measure their temperatures, and even study their weather patterns, all from our vantage point on Earth. The diamond planet represents more than just a scientific curiosity. It stands as proof that the universe operates on a scale that dwarfs our grandest aspirations. In our solar system, we find worlds of gas, ice, and rock. But out there in the cosmic ocean, nature has fashioned entire planets of diamond, proving that reality surpasses even our boldest predictions. Every new world we discover adds another piece to the cosmic puzzle, teaching us something new about how planets form, how they evolve, and ultimately about our own place in this vast cosmic arena. As we continue exploring, each discovery reminds us that we've only begun to uncover the treasures waiting in the darkness between the stars. Take a look at your hand. Every atom making up your skin, muscles, and bones has an incredible story to tell. These atoms didn't just appear out of nowhere. They were forged in the hearts of dying stars billions of years ago. The iron in your blood, the calcium in your bones, the carbon in your cells, each one was created in a cosmic furnace more powerful than anything we could ever build on Earth. Let's trace this cosmic recipe back to its source. About 13.8 billion years ago, moments after the Big Bang, the universe contained only the simplest elements, hydrogen and helium, with trace amounts of lithium. But when you look at a human body, you'll find over 60 different chemical elements. Every one of these elements heavier than helium had to be manufactured in stars through a process called stellar nucleosynthesis. Here's how it works. Deep inside stars, temperatures reach millions of degrees. Under these extreme conditions, hydrogen atoms slam together with enough force to fuse into helium. This fusion releases enormous amounts of energy, the same energy that makes stars shine. But stars don't stop at helium. As they age, they begin fusing heavier and heavier elements, creating carbon, nitrogen, oxygen, and eventually iron. These stellar forges operate on an almost unimaginable scale. Every second, our Sun fuses 600 million tons of hydrogen into helium. That's more mass than Earth's entire human population, and our Sun is just one of the smaller stellar factories out there. The largest stars can fuse elements much faster and create even heavier elements. But the real magic happens when these stellar factories reach the end of their lives. Stars like our Sun will eventually swell into red giants, shedding their outer layers into space in spectacular nebulae. These clouds of stellar material will eventually mix with the surrounding gas and dust, becoming the building blocks for new stars, new planets, and yes, even new life. For the biggest stars, the end is far more dramatic. When massive stars exhaust their fuel, they explode in tremendous supernovas. These explosions are so powerful they can briefly outshine entire galaxies. In the extreme temperatures and pressures of these explosions, even heavier elements are created in a process called supernova nucleosynthesis. Gold, silver, platinum. All these precious metals were born in the final moments of dying stars. The numbers are staggering. Scientists estimate that the atoms in your body have been recycled through at least 3 different stars over the universe's history. The iron atoms in your blood were likely created in dozens of different stellar explosions, each one scattering these elements across vast regions of space. Think about the carbon in your cells. Every carbon atom in your body was created when 3 helium nuclei fused together in the intense heat of a dying star. This process, known as the triple alpha process, had to happen countless times to create enough carbon for life as we know it. Without stars reaching the precise temperature needed for this fusion, carbon-based life wouldn't exist. The story gets even more remarkable when we look at specific elements. The calcium in your bones was likely created in several different stellar explosions. The potassium that helps your nerves function was forged in ancient supernovas. Even the trace elements in your body, like the zinc that helps your immune system or the selenium in your proteins, all came from stellar processes billions of years ago. These elements didn't arrive on Earth in their pure form. They were scattered through space in enormous clouds of gas and dust. Over millions of years, gravity pulled these clouds together, forming new stars and planets, including our solar system. The early Earth was bombarded by meteors and asteroids, many containing these heavy elements created in distant stellar explosions. When we study meteorites that fall to Earth today, we can see this cosmic history preserved. Some contain grains of material that predate our solar system, tiny pieces of ancient stars that exploded billions of years ago. These pre-solar grains, as scientists call them, are literal pieces of stardust that have survived since before our sun was born. The atoms in your body have been on an incredible journey. They've existed in the hearts of stars, traveled through vast clouds of interstellar gas, become part of our planet, and eventually became incorporated into living things. The same atoms that were once part of ancient stars are now part of you, reading these words, thinking these thoughts. This connection to the cosmos isn't just poetic. It's a fundamental truth about our existence. Every breath you take contains atoms that have existed for billions of years. The water you drink contains oxygen atoms forged in stellar furnaces. The salt on your food contains sodium and chlorine created in stellar explosions before our solar system existed. We are, in the most literal sense, children of the stars. Our bodies are made of recycled stellar material, assembled and reassembled countless times over the history of the universe. When astronomers say we're made of stardust, they're not speaking metaphorically. They're describing the actual physical reality of our cosmic inheritance. Hollywood has taught us to expect something spectacular. A massive star explodes in a supernova, and we hear the thunderous boom. Two galaxies collide, and there's a cosmic crash. A meteorite streaks across the sky with a whistling screech. But the reality of space tells a different story. In the vast expanse beyond our atmosphere, these cosmic events play out in perfect silence. The truth about sound in space challenges everything movies have shown us. When the Death Star exploded in Star Wars, in reality, there would have been no sound. When asteroid impacts rocked the moon in Deep Impact, the collisions would have been silent. Even the massive stellar explosions we can see through our most powerful telescopes are occurring in absolute silence. Let's break down why this happens. Sound is a wave, but unlike light or radio waves, it's mechanical. This means sound needs a medium, something physical to travel through. On Earth, this medium is typically air. When an object makes a sound, it creates vibrations that push air molecules together and apart, creating waves of pressure that travel to our ears. These pressure waves are what we interpret as sound. But space is nearly a perfect vacuum. Between stars, the average density is just 1 atom per cubic centimeter. To put that in perspective, the air we breathe on Earth contains about 25 billion molecules per cubic centimeter. That's such an enormous difference that it's almost impossible for sound waves to form in space. Take a supernova. one of the most energetic events in the universe. When a massive star explodes, it releases more energy in a few seconds than our sun will produce in its entire lifetime. On Earth, an explosion creates a shock wave through the air that we hear as a boom. But in space, that same explosion has no air to push against. The energy disperses as light, radiation, and particles, but there's no medium to carry the sound. The same principle applies to smaller cosmic events. When meteors streak through Earth's atmosphere, they create the familiar sound of something breaking the sound barrier. But in space, these same objects travel in silence, only beginning to make noise when they hit the thicker air of our atmosphere. This silence extends to human activities in space as well. When astronauts conduct spacewalks outside the International Space Station, they can't hear any external sounds. The only sounds they hear come through direct contact with their equipment or through radio communications. Two astronauts floating just feet apart in space couldn't hear each other speak without their radio links, even if they were shouting. However, space isn't completely devoid of all kinds of waves. While sound waves can't travel through the vacuum, other types of waves can. Light waves, radio waves, X-rays, and gamma rays all travel perfectly fine through space. These electromagnetic waves don't need a medium to propagate, which is why we can see distant stars and receive radio signals from far-off space probes. Scientists have also discovered something fascinating. While space itself might be silent, the objects in it can create types of waves that, when converted to sound, produce eerie and remarkable noises. NASA has recorded what they call the sounds of space by converting electromagnetic waves and particle interactions into audible frequencies. The results are haunting. Jupiter's magnetic field creates swooshing noises. Saturn's rings produce hissing sounds, and even black holes have their own deep, resonant frequencies. Consider what this means for some of the most dramatic events in our cosmic neighborhood. When solar flares erupt from the sun's surface, hurling billions of tons of material into space, there's no thunderous roar. When comets break apart under the sun's heat, there's no cracking sound. When asteroids collide in the belt between Mars and Jupiter, their impacts are silent ballets of destruction. The reality of this cosmic silence adds another layer of awe to space exploration. Astronauts who've experienced spacewalks often describe the profound silence they encounter. Against the backdrop of our noisy Earth, where we're constantly surrounded by sounds, the absolute silence of space creates a stark contrast that many find deeply moving. This silence also has practical implications for space travel and exploration. Without sound waves to carry vibrations, spacecraft designers need to account for how energy and forces will be transmitted differently in space. Heat management becomes crucial because without air to carry away heat through convection, objects in space can only cool by radiating heat directly into the vacuum. The absence of sound in space also helps us appreciate just how special our Earth is. Our atmosphere doesn't just make sound possible, it creates the acoustic environment that shaped the evolution of life. Birds, whales, and countless other creatures evolved to communicate through sound waves, precisely because our planet provides the medium needed for sound to travel. But perhaps most fascinating is how this cosmic silence influences our understanding of the universe. Since we can't hear what's happening in space, we've had to develop other ways to study cosmic events. We use light across the electromagnetic spectrum, gravitational waves, and particle detectors to understand what's happening in the silent void above us. 63 light-years from Earth lies a world that makes our most extreme weather look gentle by comparison. HD 189733b is a planet where storms don't just bring water or ice, they bring scorching drops of molten glass, hurled sideways by winds that move 7 times faster than the speed of sound. This blue giant is what astronomers call a hot Jupiter, a massive gas planet orbiting perilously close to its star. At just 2.9 million miles from its sun, 1/3 the distance between Mercury and our Sun, HD 189733b, experiences heat and radiation that create weather conditions unlike anything in our solar system. Let's put these conditions into perspective. The winds on this planet reach speeds of 5,400 miles per hour. During Earth's most powerful hurricanes, wind speeds rarely exceed 200 miles per hour. The fastest winds ever recorded on our planet during a 1999 Oklahoma tornado reached just 318 miles per hour. The winds on our glass-raining planet are nearly 17 times stronger than that. But it's not just the wind speed that makes this planet extraordinary. The temperature reaches 1,700 degrees Fahrenheit during the day, hot enough to melt silicon. At these temperatures, particles of silicate in the atmosphere vaporize into glass. These particles then condense into drops of molten glass, much like water vapor condenses into raindrops in Earth's atmosphere. The combination of extreme temperatures and those hypersonic winds creates something unprecedented: sideways glass rain. The wind speeds are so intense that the molten glass drops don't fall straight down. Instead, they're whipped sideways across the planet's atmosphere in vast scorching storms that never end. The composition of these glass raindrops reveals another layer of extremity. Scientists studying HD 189733b have determined that the drops are likely made of silicate particles similar to ruby and sapphire. Using specialized telescopes, researchers have detected significant amounts of magnesium silicate in the planet's atmosphere. When this material melts and reforms in the brutal conditions, it creates the glass-like drops that perpetually storm across the planet. The planet's proximity to its star creates another fascinating phenomenon: tidal locking. Like our moon always shows the same face to Earth, this planet always presents the same side to its star. This creates a permanent day side and night side, with temperatures varying by hundreds of degrees between them. This temperature difference helps drive the planet's extraordinary wind speeds as hot air from the day side rushes toward the cooler night side. The day-night temperature variation also affects the glass rain cycle. On the day side, temperatures are high enough to vaporize the silicate particles completely. As these particles move toward the night side, they cool and condense into drops, creating a perpetual cycle of vaporization and condensation. This process is similar to Earth's water cycle, but at temperatures that would instantly vaporize any known substance on our planet. The atmospheric pressure on this planet adds another dimension to its extreme conditions. The pressure is so intense that the glass rain forms at higher altitudes than rain would on Earth. As the drops fall through the increasingly dense layers of atmosphere, they're subjected to even more heat and pressure, potentially changing their composition before they reach the lower atmospheric layers. Recent observations using the Hubble Space Telescope have revealed even more details about this bizarre world. The planet appears to have a deep blue color, but unlike Earth, this isn't from oceans of water. The blue comes from light scattered by silicate particles in its atmosphere. the same particles that form the glass rain. The extreme conditions on HD 189733b also create unique atmospheric chemistry. The intense heat breaks down molecules in the atmosphere, creating a complex soup of ions and charged particles. This ionized atmosphere interacts with the magnetic field of the planet star, creating auroras far more powerful than Earth's northern lights. Scientists studying this have also detected traces of other elements in its atmosphere, including sodium, potassium, and possibly even carbon dioxide. These discoveries help us understand how planets form and evolve under extreme conditions. Each new observation of this world provides insights into planetary physics that we simply can't study in our own solar system. The discovery and study of this glass-raining planet represents a triumph of modern astronomy. We can analyze the atmosphere of a planet 63 light-years away, measure its wind speeds, and determine the composition of its clouds, all using telescopes and instruments on or near Earth. Each new detail we learn about this world pushes the boundaries of our understanding of what's possible in planetary science. Europa, one of Jupiter's largest moons, broadcasts something extraordinary into space. While we know sound can't travel through the vacuum of space, this moon generates powerful electromagnetic emissions that, when converted to sound waves, produce otherworldly roars and screams that sound like something from a sci-fi horror movie. These sounds come from an incredible interaction between Europa and its parent planet. Jupiter possesses the most powerful magnetic field in our solar system, 20,000 times stronger than Earth's. This massive magnetic field sweeps past Europa as the moon orbits through it, creating a complex dance of electromagnetic energy. When NASA's Galileo spacecraft captured these emissions and scientists converted them to sound, they discovered something unexpected. The interactions created rising and falling tones, punctuated by sudden bursts of energy that sound remarkably like roars and screeches. The frequencies of these emissions, which typically occur in the range of 50 to 200 kilohertz, had to be shifted down into the range of human hearing to be audible. The source of these emissions lies deep beneath Europa's icy surface. This moon harbors a global ocean of liquid water, containing more than twice the amount of water in all of Earth's oceans combined. This vast subsurface ocean is naturally conductive due to dissolved salts. As Europa moves through Jupiter's magnetic field, it acts like a giant electromagnetic generator, creating powerful electrical currents. These currents don't just stay contained within Europa. They burst outward into space, creating what scientists call a magnetic footprint in Jupiter's upper atmosphere. When these electrical currents interact with charged particles trapped in Jupiter's magnetic field, they produce the distinctive radio emissions we can detect. The pattern of these emissions tells us something crucial about Europa's ocean. The strength and consistency of the signals suggest that the ocean is incredibly salty, perhaps even more so than Earth's Dead Sea. This high salt content makes the water extremely electrically conductive, which in turn makes the electromagnetic interactions with Jupiter's magnetic field more powerful. The timing of these emissions also reveals a complex pattern. They become stronger and weaker as Europa orbits Jupiter, creating a natural rhythm that scientists can use to better understand both the Moon and its parent planet. This variation occurs because Europa's position relative to Jupiter's magnetic field changes throughout its orbit, affecting the strength of their electromagnetic interaction. Scientists studying these emissions have discovered that they're not random. They follow specific patterns tied to Europa's orbital position and the structure of Jupiter's magnetic field. During certain parts of Europa's orbit, the emissions become particularly intense, creating what scientists call chorus waves. These waves, when converted to sound, produce rising tones that sound almost like dawn chorus birds on Earth, but with a distinctly alien quality. The strength of these emissions provides valuable data about Europa's subsurface ocean. By measuring their intensity and frequency, scientists can estimate the ocean's depth, salinity, and even its movement patterns. This information is crucial for understanding the potential habitability of this fascinating moon. Recent observations have revealed even more complexity in these electromagnetic interactions. The emissions change when Europa passes through different regions of Jupiter's magnetosphere. Sometimes they produce smooth rising tones. Other times they create burst-like sounds that scientists call chorus elements. These variations help map the structure of Jupiter's massive magnetic field. The discovery of these emissions has practical implications for future missions to Europa. Any spacecraft visiting the Moon will need special protection from these powerful electromagnetic forces. The electrical currents generated by the interaction between Europa and Jupiter's magnetic field could potentially interfere with spacecraft electronics or communication systems. These electromagnetic emissions also serve another purpose. They help heat Europa's ocean. The electrical currents generated by these interactions produce heat through a process called tidal heating. Combined with the gravitational effects of Jupiter, this heating helps keep Europa's subsurface ocean liquid, despite the Moon's location far from the Sun, where temperatures should be well below freezing. NASA's upcoming Europa Clipper mission will study these emissions in unprecedented detail. The spacecraft will carry instruments specifically designed to measure the strength and patterns of Europa's electromagnetic interactions with Jupiter. These measurements will provide new insights into the depth and composition of Europa's ocean, as well as the complex dynamics of Jupiter's magnetic field. When the raw data from these emissions is converted into sound, it creates an eerie audio landscape. Low, rumbling growls suddenly transform into high-pitched screams. Whistling tones rise and fall like alien sirens. Burst-like sounds punctuate the audio like distant explosions. Together, they form what scientists call Europa's song, a complex symphony of electromagnetic energy that reveals the powerful forces at work in the Jupiter system. Between Mars and Jupiter floats an object that defies our expectations of what an asteroid should be. Ceres, now classified as a dwarf planet, stretches 587 miles across, making it the largest object in the asteroid belt. But size isn't what makes this world extraordinary. Deep beneath its cratered surface lies something unexpected, a vast reservoir of liquid water. This discovery came from NASA's Dawn mission, which spent nearly 3 years studying Ceres up close. The spacecraft's instruments revealed that this supposed space rock is actually a layered world, with a rocky core surrounded by an ice-rich crust. But the most surprising finding was evidence of a deep layer of briny liquid stretching across the entire dwarf planet. The numbers tell an incredible story. Scientists estimate this reservoir contains about 40 million cubic kilometers of water. That's more water than all of Earth's freshwater lakes combined. This water isn't pure like what we drink on Earth. It's mixed with salts and various minerals, creating a natural antifreeze that keeps it liquid despite the cold temperatures of the asteroid belt. When Dawn arrived at Ceres in 2015, it spotted something peculiar. Bright white spots dotting the surface, particularly in a crater called Okator. These spots turned out to be salt deposits left behind when water from the underground ocean seeped up through cracks and evaporated into space. The largest of these spots in Okator crater spans about 30 square miles, making it visible even from Earth with powerful telescopes. The composition of these salt deposits reveals the complex chemistry of Ceres' hidden ocean. They contain sodium carbonate, the same compound used in water softeners, along with ammonium chloride and other salts. This chemical mixture suggests that the underground ocean is still actively interacting with the rocky material beneath it, potentially creating conditions similar to those in Earth's deep-sea hydrothermal vents. Recent analysis shows that this ocean isn't just a relic of the past, it's still active today. The bright spots in Okator crater are estimated to be only about 2 million years old, incredibly young by astronomical standards. This means that somehow Ceres has maintained enough internal heat to keep its underground ocean liquid for billions of years. The source of this heat remains one of Ceres' most intriguing mysteries. Unlike Europa or Enceladus, which are heated by the gravitational effects of their massive parent planets, Ceres floats freely in the asteroid belt. Scientists think radioactive decay in its rocky core might provide some heat, but there may be other processes at work that we don't yet understand. Data from Dawn's gravity measurements revealed another surprise. Ceres' interior isn't uniform. The underground ocean varies in depth and composition, suggesting a complex geological history. In some regions, the liquid layer might be just a few miles below the surface. In others, it could be buried much deeper. The discovery of this ocean changes our understanding of Ceres' history. What was once thought to be just a large, dead rock turns out to be a geologically active world. The presence of liquid water, combined with organic compounds that Dawn also detected, raises intriguing possibilities about potential past or present biological activity. Studies of the crater patterns on Ceres' surface tell us even more about its ocean. The way these craters have deformed over time suggests that the dwarf planet's crust is far weaker than it should be if it were made of pure ice. This weakness is best explained by the presence of liquid below, allowing the surface to slowly shift and flow. The temperature variations on Ceres create a unique environment. At the equator, surface temperatures can reach a relatively warm -38 degrees Celsius during the day, dropping to -113 degrees at night. Despite these frigid conditions, the underground ocean remains liquid thanks to its salt content and the pressure from the layers of rock and ice above it. Recent research suggests that Ceres' ocean might be slowly freezing, but this process takes place over billions of years. As the water freezes, it expands, creating cracks in the surface ice. These cracks then allow more material from the ocean to seep up, creating the bright spots we see today. It's a continuous cycle that keeps Ceres geologically active. Dawn's measurements also revealed that Ceres is surprisingly rich in water ice, with some regions containing up to 40% ice by volume. This high ice content, combined with the presence of organic compounds, suggests that Ceres might have formed in a colder region of the solar system before migrating to its current position in the asteroid belt. Koros 7b stands as a monument to just how extreme a planet can become. Located 489 light-years from Earth, this world makes Venus look like a winter resort. Its surface is a churning ocean of molten rock, where the very ground itself melts, vaporizes, and rains back down in an endless cycle of destruction. The temperatures on this hellish world reach 4,000 degrees Fahrenheit. That's hot enough to vaporize titanium. The planet orbits so close to its star that a year lasts just 20 hours. This extreme proximity means one side of the planet permanently faces its star, creating a day side that's hot enough to melt rock into a vast lava ocean, hundreds of miles deep. The physics at work here creates something unprecedented in our solar system. The heat is so intense that rock doesn't just melt, it vaporizes. Common minerals like silicates and metals turn directly into gas, creating a unique type of atmosphere. As these vaporized rocks rise into the slightly cooler upper atmosphere, they condense and fall back to the surface as drops of molten rock. Picture a weather forecast for this world. Today's outlook calls for scattered sodium rain in the morning, followed by heavy downpours of molten iron in the afternoon, with a chance of liquid ruby storms by evening. The different minerals in the planet's makeup vaporize at different temperatures, creating distinct layers of metallic and rock vapor in the atmosphere. Scientists studying this superheated world have detected evidence of minerals raining from the sky that we consider precious stones on Earth. Corundum, the mineral that forms rubies and sapphires, could theoretically rain from these alien skies, though it would be just another component in the endless cycle of vaporization and precipitation. The night side of this planet tells an equally extreme story. While the day side boils at thousands of degrees, the night side might be relatively cool at around 2,200 degrees Fahrenheit, still hot enough to melt lead, but cool enough for some of the vaporized rock to solidify before falling back to the surface. The extreme temperature difference between the day and night sides creates savage winds, possibly reaching supersonic speeds. These winds carry vaporized rock from the day side to the night side, where it condenses and rains back down as molten droplets. This creates a constant cycle of rock rain that helps redistribute heat across the planet's surface. The gravity on this world is roughly twice that of Earth, which actually helps hold on to its unusual atmosphere. Despite the intense heat constantly trying to blow the atmosphere away into space, the strong gravity manages to retain a thick layer of vaporized rock around the planet. The surface pressure adds another layer of extremity to this world. Under such intense conditions, the molten rock ocean wouldn't behave quite like a liquid on Earth. The pressure and heat combine to create a substance that's somewhere between a liquid and a supercritical fluid, with properties scientists are still working to understand. Recent observations have revealed that the lava ocean has its own weather patterns. Just as Earth's oceans have currents, this planet's lava ocean likely has massive convection cells, moving heat around through the liquid rock. These currents, combined with the planet's rotation, probably create patterns of hotter and cooler regions in the lava ocean. The discovery of this world has forced scientists to expand their understanding of what constitutes an atmosphere. While we typically think of atmospheres as being made of gases like nitrogen and oxygen, this planet proves that under the right conditions, even rock can form an atmosphere. The interaction between the molten surface and the vaporized rock atmosphere creates a unique form of erosion. The constant cycle of vaporization and precipitation slowly breaks down any surface features, essentially recycling the entire surface of the planet through the atmosphere over time. Studying this extreme world helps scientists understand the limits of planetary formation and evolution. It represents a type of planet we don't have in our solar system, a superheated rocky world so close to its star that traditional concepts of geology break down completely. Corot 7b serves as a perfect example of how diverse and extreme planets can become, pushing the boundaries of what we once thought possible in planetary science. In 2011, NASA's Kepler Space Telescope made a discovery that seemed to leap straight from Star Wars into reality. Just like the fictional planet Tatooine, Kepler 16b became the first confirmed planet orbiting two stars simultaneously, proving that binary star systems can indeed host planets in stable orbits. Located 245 light-years from Earth, this gas giant rewrites our understanding of how planetary systems form and survive. The numbers behind this extraordinary world tell a fascinating story. The two stars it orbits couldn't be more different. The primary star is about 69% the mass of our Sun, while its companion is much smaller, only 20% of the Sun's mass. These stars dance around each other every 41 days, while the planet circles both stars in an orbit that takes 229 days to complete. But what makes this system truly remarkable is its clockwork precision. Despite having two gravitational forces pulling on it, the planet maintains an almost perfectly circular orbit. This stability comes from the planet orbiting at just the right distance from both stars, about 65 million miles out, placing it in a sweet spot where the competing gravitational forces balance each other. The daily cycle on this world creates a spectacle unlike anything in our solar system. As the planet rotates, an observer on its surface would witness an elaborate dance of light and shadow. Sometimes both stars appear in the sky together, creating regions of double shadows. Other times, one star sets while the other remains visible, creating complex patterns of light that change throughout the planet's year. The discovery of this world sparked a revolution in our search for planets. Scientists had long debated whether planets could form and survive in binary star systems. The fact that such a world exists, and in such a stable orbit, suggests that planets around binary stars might be much more common than previously thought. Temperature variations on the planet follow patterns far more complex than those on Earth. When both stars are visible, the planet receives their combined heat and light. During periods when only one star is visible, the temperature drops accordingly. This creates a climate system that varies not just by season and latitude, but also by the relative positions of both stars in the sky. The composition of this gas giant adds another layer of intrigue to its story. About the size of Saturn, this planet is primarily made of gas, with a solid core buried deep beneath its cloudy atmosphere. The atmospheric patterns likely follow bizarre cycles, as the varying heat from the two stars creates complex wind patterns and storm systems. Recent studies of the system have revealed even more surprises. The orbit of the planet is almost perfectly aligned with the orbit of its two parent stars, suggesting that it formed from the same disk of material that formed both stars. This alignment helps explain how the planet has maintained its stable orbit over billions of years. The discovery opened up new possibilities in our search for habitable worlds. While this world itself is too cold and gaseous to support life as we know it, its existence proves that planets can form and persist in binary star systems. Given that about half of all stars in our galaxy exist in binary or multiple star systems, this dramatically increases the number of places where we might find potentially habitable worlds. Scientists studying this system have also gained new insights into planetary formation. The presence of a planet in a binary system challenges traditional models of how planets form and evolve. It suggests that the process of planetary formation is more robust than previously thought, capable of producing stable worlds even in the complex gravitational environment of two stars. The precision of the planet's orbit serves as a natural laboratory for testing our understanding of orbital mechanics. The planet's movement around both stars follows patterns predicted by physical laws with remarkable accuracy, allowing scientists to refine their models of how objects behave in complex gravitational fields. Among the countless worlds scattered across our galaxy lies a peculiar giant that challenges everything we know about planetary physics. In 2011, astronomers discovered a world so dark it seems to swallow nearly all light that touches its surface. This gas giant, called TRIPPY, orbits a sun-like star in the Draco constellation and holds a record in our astronomical catalogs as the darkest planet ever observed. When we talk about darkness in space, we typically think of the void between stars or the inky blackness of a moonless night. But this mysterious world takes darkness to an entirely new level. This mysterious world absorbs an astounding 99% of all light that falls upon its surface, reflecting back less light than black acrylic paint. To put this in perspective, even coal reflects more light than this enigmatic planet. Located approximately 750 light-years from Earth, this planet belongs to a class known as hot Jupiters, massive gas worlds that orbit perilously close to their parent stars. Unlike the serene, banded beauty of our own Jupiter, this world presents an entirely different face to the cosmos. Its atmosphere is a tempestuous mix of light-absorbing chemicals, including vaporized sodium and potassium, along with gaseous titanium oxide, all of which contribute to its extraordinary darkness. The planet's proximity to its star subjects it to intense heat, with surface temperatures reaching a scorching 1800 degrees Fahrenheit. At such temperatures, any conventional clouds we might be familiar with are impossible. Instead, the atmosphere contains exotic compounds that, rather than reflecting light like Earth's clouds, consume it almost entirely. What makes TRIPPY particularly fascinating is the paradox of its existence. Despite being so close to its star that it completes an orbit in just 2.5 Earth days, and despite being bathed in stellar radiation 700 times more intense than what Earth receives, this world remains stubbornly, impossibly dark. The small amount of light it does reflect gives it a faint red glow, like a dying ember in an endless night. The mechanics behind this planet's extreme darkness challenged our understanding of planetary physics. Scientists initially struggled to explain how any planet could absorb so much light. The discovery forced us to revise our models of how planetary atmospheres interact with stellar radiation and helped us understand that worlds can exist in forms far more extreme than we previously thought possible. The planet's discovery was made possible by NASA's Kepler Space Telescope, which detected the subtle dimming of the parent star as our dark planet passed in front of it. But it was the careful measurement of the planet's albedo, or reflectiveness, that revealed its true nature. With an albedo of less than 1%, it is more light-absorbent than any natural material found on Earth. This world represents more than just an astronomical curiosity. It stands as a testament to the incredible diversity of planets that exist in our galaxy. While Earth, with its blue oceans and white clouds, reflects about 30% of the sunlight that reaches it. This planet shows us that planets can exist at the opposite end of the reflectivity spectrum. The study of TRES 2b has opened new avenues in our understanding of exoplanet atmospheres. Its existence raises intriguing questions about the chemistry and physics at play on other worlds. Could there be planets even darker? What other extreme properties might we discover as we continue to explore the cosmos? In the grand tapestry of space, this dark planet serves as a reminder that the universe has not exhausted its capacity to surprise us. Each new discovery pushes the boundaries of what we think is possible, challenging our preconceptions about the nature of worlds beyond our solar system. This dark giant, eternally circling its star in a dance of shadow and heat, continues to captivate astronomers and fuel our curiosity about the true diversity of planets that populate our cosmic neighborhood. As our telescopes peer deeper into space and our instruments become more refined, we may find other worlds that rival this level of darkness. But for now, TRES 2b stands alone, a black pearl in the cosmic ocean, challenging our understanding of what's possible in the universe. Here's something that will blow your mind. One of Earth's most intelligent creatures might not be from Earth at all. Deep in our oceans lives an 8-armed genius that has puzzled scientists for decades. The octopus, with problem-solving skills that surpass most other animals and an ability to edit its own genetic code, stands as one of the most bizarre creatures in our biological record. What makes these creatures truly extraordinary is their genetic makeup. The octopus genome contains 33,000 protein-coding genes, significantly more than humans who have about 20,000. This complexity places them among the most genetically elaborate creatures we've ever studied. But it's not just the number of genes that makes scientists scratch their heads. It's the way these genes are arranged and how they can be modified. One of the most mind-boggling abilities of octopuses is their power to edit their RNA on the fly, allowing them to adapt to their environment without waiting for evolutionary changes. This process, known as RNA editing, happens in all animals, but octopuses do it at an unprecedented scale. They can modify their proteins to work better in different temperatures, essentially rewriting their own operating system in real time. The way octopuses use their arms defies conventional neuroscience. Each arm contains its own independent nervous system, meaning these creatures essentially have 9 brains. A central brain plus 8 additional processing centers, 1 in each arm. This level of neural complexity is unlike anything else we've found on Earth. Their intelligence manifests in ways that seem almost alien. They can solve complex puzzles, escape from sealed containers, use tools, and even demonstrate what appears to be play behavior. They can change their skin color and texture in milliseconds, displaying patterns and colors that many scientists believe form a sophisticated language we're only beginning to understand. These extraordinary features led to one of the most controversial scientific papers in recent history. In 2018, a group of 33 scientists published a peer-reviewed paper in Progress in Biophysics and Molecular Biology that suggested something radical. Octopuses might have originated from space. The paper proposed that fertilized octopus eggs could have arrived on Earth frozen in comets during the Cambrian explosion, a period when complex animal life suddenly appeared in the fossil record. While most scientists disagree with this hypothesis, pointing out that we can trace octopus evolution through the fossil record. The very fact that such a theory could be published in a respected scientific journal speaks to how extraordinary these creatures truly are. The paper highlighted an important truth. The emergence of octopuses with their complex features seemingly appearing out of nowhere in evolutionary terms remains one of biology's most fascinating mysteries. The reality of octopus evolution might be even stranger than the extraterrestrial hypothesis. These creatures developed their intelligence completely independently from vertebrates like mammals and birds. While our ancestors were still swimming in prehistoric seas, octopuses were already developing problem-solving skills that would rival those of modern mammals millions of years later. Their ability to solve problems rivals that of a 3-year-old human child. They can unscrew jar lids, navigate mazes, and even learn by watching other octopuses solve problems. In captivity, they've been known to squirt water at lights to short-circuit them, suggesting not just intelligence, but a sophisticated understanding of cause and effect. Perhaps most remarkably, every octopus is born with these abilities. Unlike humans, who learn most of their skills from their parents and society, octopuses emerge from their eggs fully equipped with their remarkable skill set. They receive no parental training, yet somehow know exactly how to camouflage themselves, catch prey, and solve complex problems. While the cosmic origin theory might sound far out, the truth about octopuses is no less incredible. Whether they came from space or evolved here on Earth, these 8-armed enigmas represent one of nature's most successful experiments in evolution. They remind us that intelligence can take forms wildly different from our own, and that the most alien-like creatures might not be in distant galaxies, but right here in our own oceans. Get ready for your mind to be completely blown, because we're about to dive into something so weird that it made Einstein himself uncomfortable. We're talking about quantum entanglement, and it's going to make you question everything you think you know about reality. Let's start with something familiar. When you text your friend, that message has to travel through space to reach them. Even at the speed of light, which is incredibly fast at 186,000 miles per second, it still takes time. If your friend was on Mars, it would take anywhere from 3 to 22 minutes for your text to reach them, depending on where Mars is in its orbit. That's just how things work in our everyday world. Everything takes time to get from point A to point B. But quantum entanglement throws all of that out the window. When particles become entangled, think of them like identical twins at the quantum level. They start behaving in a way that seems impossible. Whatever happens to one particle instantly affects its entangled partner, no matter how far apart they are. And when we say instantly, we mean it literally breaks the speed limit of the universe. Here's an analogy that might help. Imagine you have 2 coins that are magically connected. Every time you flip one coin, the other coin instantly shows the same result, whether it's heads or tails. Now spread those coins apart, so one is on Earth and one is in the Andromeda galaxy, 2.5 million light-years away. Flip the coin on Earth, and the one in Andromeda would show the same result before light could even travel a single inch. This is exactly what happens with entangled particles, and scientists have actually proven this in laboratories. But it gets even weirder. These entangled particles don't decide their state until you measure them. It's like those magical coins don't actually land on heads or tails until someone looks at them. And somehow, when you look at one coin, Both coins instantly agree on what they're showing, no matter how far apart they are. Think about playing a game of rock, paper, scissors with someone on the opposite side of the universe. In our normal world, you'd both make your choice and then wait billions of years for light to carry the information about who won. But if your hands were quantum entangled, they would somehow always make perfectly matching or perfectly opposing choices the instant you played, with no time delay at all. It's as if the universe doesn't care about distance when it comes to entangled particles. This phenomenon freaked Einstein out so much that he called it spooky action at a distance. He thought there must be some hidden explanation because it seemed to violate his theory of special relativity, which says nothing can travel faster than light. But decades of experiments have proven that this spooky action is real. The most recent tests have shown that if there is any speed limit to entanglement at all, it must be at least 10,000 times faster than the speed of light. To really appreciate how bizarre this is, imagine you have two decks of cards. You shuffle each deck and give one to your friend. Your friend travels to the other side of the universe. If these were quantum entangled decks, every time you pulled a card from your deck, your friend would instantly pull the matching card from their deck. Not a second later, not a microsecond later, but truly, instantly. It's like the two decks are actually one thing, even though they're separated by billions of light years. Scientists are now trying to use this weird quantum connection to build totally unhackable communication systems and super powerful quantum computers. They've already managed to entangle particles across cities and even between Earth and satellites in space. But perhaps the wildest thing about quantum entanglement is what it suggests about the nature of reality itself. The fact that entangled particles can influence each other instantly across any distance suggests that space itself might be an illusion. At some deeper level, points that seem infinitely far apart in our universe might actually be right next to each other. It's as if our whole universe is like a giant hologram, where everything is connected to everything else in ways we can't see, but quantum particles can somehow access. Some physicists think quantum entanglement might be the key to understanding consciousness, parallel universes, and even time itself. Maybe our brains use quantum entanglement in some way we don't yet understand. Maybe parallel universes are quantum entangled with each other. Maybe the past and future are quantum entangled with the present. The next time you look up at the stars, remember that the vast distances you see might not be as absolute as they appear. Through quantum entanglement, every point in the cosmos is connected to every other point in ways that transcend space and time. It's like the universe has its own instantaneous social network, where particles can stay in perfect sync across billions of light years, breaking the rules of space and time as we know them. This isn't science fiction. This is real, proven science happening in laboratories right now. And it might just be our first glimpse at an even deeper reality that we're only beginning to understand. In a way, quantum entanglement is telling us that everything in the universe is connected in ways we never imagined possible. Pretty trippy, right?